Complexity of products knows no limits today. These products are a complex combination of many elements working together. For example, the model shown here consists of an IC on a package, a PCB with a connector, a cable with two antennas, one on top for GPS and a camera and the other one on the bottom for remote control, and 4 blades as part of a drone. Such products are an example of a true system. The solutions that exist today neglect several electromagnetic effects since it's possible to simulate such full systems together. Traditionally, engineers have been compelled to simulate each of these components, for example, the package, the PCB, connectors, cables, and antennas separately. But now, the new groundbreaking HFSS mesh fusion technology will make simulating full systems together possible without compromising on accuracy. You can easily select all the components in a system upon which you want to apply mesh fusion technology and choose a meshing method of your choice for any components in your system and quickly simulate the whole system together. Generating the mesh for this complex system is easy. To view the mesh of the drone structure, simply click on the option under Field Overlay. You can also plot the fields of the complete system in a similar way and visualize the fields under Field Overlay. Generating S parameters of this large EM system is the same as with an HFSS simulation. For example, you can simply go to Network Data Explorer under Analysis option to view various S parameter plots. Quickly select and extract the S parameters you need into a touchstone file or any other output file format. And use this file for your downstream circuit and system simulation needs. Simulation is the key to breakthrough innovation, and HFSS mesh fusion technology provides the capacity to simulate such large complex systems in one go with the gold standard accuracy and reliability of HFSS. Assemble your design with 3D components, and mesh fusion will simulate your entire system together without compromising any accuracy. Be it a system with IC packaging, PCBs, and cables, or a co-site problem with multiple antennas in a single aircraft antenna, or even a touchscreen panel TV in an EMI chamber, mesh fusion technology has the sophistication and capacity to solve any complex electromagnetic system. Try this new technology and stretch the simulation horizons on your design today. Simulate your complete system with the confidence of Ansys HFSS. It has always been a challenge to perform mechanical thermal simulation on the designs created in an electromagnetic tool. The traditional processes have forced designers to waste a lot of time by passing the electromagnetic analysis results over to thermal engineers and wait for their response. We want to change all that by empowering electrical designers with quick thermal insight. Here is an example of an HFSS design. We aim to determine the mechanical heat profile of this package. This package is mounted on a board, and we have input and output transmission lines here. Embedded in this package would be an RF power amplifier with bond wires on the input, output, and ground plane. The signal coming in from the input will be amplified by the chip to the output as we would expect. At this stage, a designer may also need to quickly see the thermal performance of this electromagnetic design. This can be easily achieved using the new mechanical thermal solution in Ansys Electronics Desktop. A user can quickly import electromagnetic designs from HFSS, Maxwell, or Q3D into mechanical for thermal analysis. First, a mechanical design type must be added in the same GUI. Copy and paste the model from the HFSS design into the mechanical design type. Assign the EM excitation loss to this model by selecting this option and link it to the HFSS source project. This shows that we are transferring the losses from the volumes of the dielectric and surface of the metal pieces and bringing them in as heat loads for mechanical. For mechanical thermal analysis, we also need to assign the convection boundaries to this model to understand how the heat transfers from its surface to the air surrounding it. Next, set up the thermal analysis and import the mesh generated from HFSS, and we are done. Run the simulation by clicking on this option. Plot the temperature fields. Now you can see exactly what's heating up in this model and its complete temperature profile. Be it for any electromagnetic designs in HFSS, Maxwell, or Q3D, Mechanical Thermal Solution in Electronics Desktop provides an FEA thermal solution, allowing design engineers the ability to get quick thermal insights into a design without any complicated setup and analysis in the same environment. Try this new workflow on your design today. Current simulation and analysis solutions make it incredibly challenging to simulate big systems like a car that include the effects of components like antennas as part of the setup. Engineers have traditionally spent a large amount of time to simulate such systems, but the results are still inaccurate. With the new capability in Ansys EMA3D Cable, you can easily simulate subsystems such as a PCB or an antenna in HFSS and bring the fields into EMA3D Cable easily to get the most accurate real-life results. The process is very simple. In HFSS, we can generate the near fields of an antenna. It is easy to take these antenna fields from HFSS into EMA3D Cable for full system simulation using the HFSS Savant datalink. Select the appropriate options here and click on Finish. This creates an XML file containing all the electric and magnetic field information of the antenna setup. The XML file can be easily imported into EMA3D Cable to perform true system simulation. Let's take an example of a system for a radiated immunity test. Here, the antenna is creating the electromagnetic field, and we need to be concerned about the noise that is generated in the wiring harness. In this situation, we can easily bring the fields of this antenna from HFSS by clicking on this option and selecting the XML file that we created earlier. Now we have the antenna source as part of the model in EMA3D Cable solution. Generating a mesh of the whole system together is easy. After the mesh is generated, simulate the whole system together and view accurate animations and results. Now, you will be able to successfully perform a true system simulation with this powerful combination of HFSS and Ansys EMA3D Cable. The complexity of electrical machines has long presented challenges for modeling and simulation. An increasing number of issues arise when 3D geometries of electric machines become more complex, but these issues remain unaddressed. Here is a full 360-degree 3D motor design geometry exported from a template-based solution like Ansys MotorCAD or RM Expert. The import from these Ansys solutions automatically assign the material characteristics and the excitations to drive this electrical machine, so the design is ready for simulation right away. But here is the challenge. If you simulate it now, it will consider the full cross-section, and that will require significant time to complete simulation. Or, to create a more manageable simulation, you would need to manually create 2 radial planar cuts to define a circumferential symmetry. Instead, with Maxwell, you can automatically solve just a fraction of the geometry by virtually slicing it. By selecting the option of Solve one circumferential fraction, you can enable the solver to automatically determine and choose the desired 3D slice depending on the existing symmetry. The solver can now use non-planar radial cuts as boundary conditions automatically when meshing. This reduces inaccuracy on matching boundaries and enhances the solution accuracy. Non-planar cuts provide more accurate resolution of matching boundaries on skewed topologies. To account for such slicing through the symmetry, select the Clone Mesh option as shown. This will create the cloned and symmetrical mesh of this 3D geometry, automatically helping you reduce the nonlinear meshing errors in the magnetic field calculation significantly. Less mesh error means less iterations are needed to reach the converged solution, thus reducing the overall simulation time. Now that all the setup is done, it's time to run the analysis. Plotting the mesh of this complex structure is easy. Magnetic flux density fields show the level of saturation in the machine, which is critical. As you can see, we are solving just a fraction of the geometry, but the fields are displayed on the full geometry. The results generated for this complex 3D structure are very fast and much more accurate compared to previous approaches. Simulation is the key to breakthrough innovation, and slice-only simulation technology in Ansys Maxwell provides the fastest and most reliable solution for simulation of any 3D complex electric machine geometry.